Section 4.2, multiplying matrices. 4 vocabulary words here. We have a matrix product, which is the product of 2 or more matrices. Last section we learned about scalar products, which is where we multiplied one number, a scalar, by a matrix and got a scalar product. A square matrix. A square matrix has the same number of rows as columns, which is called a 2 by 2 or a 3 by 3, or if you want to use a variable, an n by n. The main diagonal of a square matrix is the diagonal from the upper left corner to the lower right corner. If you had a matrix here in numbers, the main diagonal is just the 1 and 4, upper left to lower right corner. Multiplicative identity matrix. Any square matrix named with the letter I that has all of the entries along the main diagonal equal to 1 and all the other entries 0. So if we had a matrix and it is lettered or named I. Okay, matrices A and B can be multiplied only if the number of columns in A equals the number of rows in B. So here we have A, which is a 2 by 3, and B, which is a 3 by 2. That just means that these numbers need to match, and that gives us our new equation. Let's do A times B equals C. C's dimensions are going to be a 2 by 2. Okay, so every time you are asked to multiply 2 matrices, you need to test it out. Write down your dimensions. If it's A times B, you can't flip it. A has dimensions of a 2 by 3, B a 3 by 2. These middle numbers have to match, and your new dimensions are the numbers that are left over, and that's right here. So dimension of the first one times dimension of the second one, these numbers have to match, and that leaves you a new dimension. Okay. Identifying matrix products. Tell whether the product is defined. If so, give its dimensions. So we have a matrix A, a matrix B. Can I multiply them together? So I have a 3 by 4 times a 4 by 2. These center numbers have to match. AB's dimensions are, and this is how we write it, a 3 by 2. The numbers that are left over. Let's try another one. Tell whether the product is defined. If so, give its dimensions. C and D, those are the dimensions. C is a 1 by 4, D is a 3 by 4. Can I multiply CD? 1 by 4 and a 3 by 4. These inner numbers do not match, so it is not defined. Okay, you try these. Okay, please notice, it always has to be in the order given. Q times P. Q is a 5 by 3, so I wrote that first. P is a 2 by 5, I wrote that next. My inner numbers don't match, so we're not defined. Same thing here, S and R. 4 by 5, 4 by 3. The inner numbers don't match, so I'm not defined. SQ. S and Q. 4 by 5, 5 by 3, my inner numbers do match, so my resulting matrix is a 4 by 3. Okay, now we're going to start multiplying matrix products, or multiplying matrices to get a matrix product. Find the product of WX. It has to be in that order if possible. The first thing we need to do is check the dimensions. W is a 3 rows by columns, and X is a 2 row, 3 column. My inner numbers match, so WX is going to be a 3 by 3. Next page, we're going to actually multiply these. Next, start multiplying. So remember, we're going to get a 3 by 3 as an answer. And multiplying takes a little bit of just concentration, because we have to go in the same order for everything or it's too confusing. What we're going to do is go across the row in W and the column in X. You're going to have to watch my numbers. So we're going to go row, column, row, column, row, column. And let's try that. And you'll see I'm just going to make a big matrix. 3 times 4 plus -2 times 5. See how I went across the row, down the column. And that goes in my first entry, my first part of the address. Next I'm going across the row and down the column. I'm putting in the next location. And again. Okay, next let's hit the second row. If you can just watch the pattern, they all work out the same. So I just went across the row of W and down each column of X. And guess what? We're going to do it for the last one. And these are all just separate entries. Sorry. 2 times 7 plus -1 times 1. 2 times -2 plus -1 times -1. Okay? And the next slide are those things added together. So it's already written on your paper, or I assume it is. I'm going to go to the next slide and actually do the addition. Okay, all I've done here is the multiplication from the last slide. Now I'm going to add them together, and we'll have our 3 by 3 matrix. I have shown more work than possibly necessary, but I wanted to show you all of the steps to get our answer. Okay, if you remember, we had a 3 by 2 times a 2 by 3. Those numbers match, so our resulting matrix was going to be a 3 by 3, which we got. Okay, let's try this again with XW. First, we need to check the dimensions. X is a 2 by 3, 2 rows, 3 columns. W is a 3 by 2. Those match, so our resulting matrix is going to be a 2 by 2. Okay, remember we're going for that 2 by 2. So we're going across and down, across and down, across and down. And let's work through this one. We have 3 times 4. Let's work on my writing. 3 times 4 plus Okay, here's a you try. Find the product if possible. First test to see if it's possible, then find the product. Go ahead and try on your own, then check your answer. There you go. I have a 3 by 2 as an answer. Okay, find the product if possible. Here we're doing CA. C is a 2 by 2. A is a 2 by 3. Those match, so we're going to be left with a 2 by 3. Go ahead and try it. Okay, that took a lot of work, but there is the answer. Let's see, I'm going to check it. Oh, I found one mistake. 48 minus 30. There's a mistake right in here. Let's see if we can find it. 12 times 4 plus 10 times positive 3. That is not a negative 3, that's a positive 3. So that would give me 78. There we go. Our answer. Nice work. Okay, now we're going to work with examples using the square matrices, main diagonals, and multiplicative identity matrix. The definitions of each of these were at the beginning of the video, and I've copied them here as a review in case you didn't write them down. Example 4, finding powers of matrices. Because square matrices can be multiplied by themselves any number of times, you can find powers of square matrices. Evaluate if possible. P cubed is like P times P times P. Okay, we can evaluate this, and I think I'm going to need another page. So let's do this one together. Get the data back. 4023 times 4023. Remember, we're going over and down. So over and down. 4 times 4 plus 0 times 2. 4 times 0 plus 0 times 3. 2 times 4 plus 3 times 2. 2 times 0 plus 3 times 3. Remember, we still have to multiply that by P one more time. But let's go ahead and simplify this. 16 plus 0 is 16. 0 plus 0 is 0. 8 plus 6 is not 12. Sorry. 14. 0 plus 9 is 9. And we still have to multiply that. Okay, excuse me, we're going to go over and down. 16 times 4 plus 0 times 2. 16 times 0 plus 0 times 3. 14 times 4 plus 9 times 2. And 14 times 0 plus 9 times 3. Let's see what that gives us. 16 times 4 is 64 plus 0. Sorry, 0 plus 0, that stays 0. 14 times 4 plus 18. And 0 plus 27. There is our cubed square matrix. Okay, why don't you, hold on. We're going to save to do this one later. I want to move on to one more thing. Evaluate if possible. This is a U-try. I'm going to talk you through it. C squared. C is a 2 by 3. If we tried to square it, we'd be multiplying a 2 by 3 times a 2 by 3. Your insides don't match, so it's not possible. A cubed. We just did one like this. So again, I'm going to hold this one off to the side for a minute. What I really want you to try is this one. If you do this one tonight and bring it in to class tomorrow, you get 2 extra points. This also tells me you watched the end of the video. And I'm going to show you how to solve this with your calculator tomorrow. But you're doing B times B times B. And it's going to be a lot of number crunching, but it's not difficult. Keep your paper organized and you can do it. I'll see you tomorrow.